Greetings. The subject of this video lecture is about the graphical transformation of functions. It's a topic belonging to the college algebra, curriculum of college algebra, and also pre-calculus. And I intend also to present it at that level. Now, the contents of this lecture can be found into the corresponding textbooks on the on the chapter that the function and their graphs are discussed. Now, before I start, let me say a few words about the mathematical meaning of transformation. Now, I'm not making any kind of formal mathematical definition for that, but give you an overall meaning of the word. Now, transformation is a mapping that maps a pre-image shape to an image of the same shape, but possibly a different size. And there are two kinds of transformation: rigid and non-rigid. And now, rigid transformation is like rotation, like translation, like rotation, translation, and reflection. They are rigid, which means they preserve the shape and the dimension and the size of the object, but not necessarily the orientation of that. All right? Now, I guess enough for the introduction. Let's start, shall we? Let's get started, shall we? Now, I have selected to impose the graphical transformation on the graph of absolute value function. So the graph of absolute value function, whether analytical graph or geometrical graph, will be going to play for us as a parent graph that we follow for transformation. Okay, now since we have selected the parent graph to be the absolute value function, so let's see exactly what absolute value function is. We analyze it perfectly for us because everything is going to be based on that in this lecture. Okay, with the word function always goes to non-empty sets, domain and range, and the rule that corresponds each element in the domain with an element in the range. That rule is in fact the function. All right. Now, let me put that one off. Since we are dealing with a function, therefore the domain of absolute value function will be the set of all real numbers. Because domain is the set of all permissible values that the independent variable can possess. And here we have no problem what value to give to x, 0, positive or negative. So the domain of that is a real number. But the range of that, which means the outcome, the output, is always non-negative. You see that? Because it's absolute value. It's always non-negative. Non-negative means 0 or positive. Now, that means we are expecting, we don't know the shape of absolute value function yet, hasn't taken form in our mind yet. But we do know that the graph of that, the sketch of the graph of that, will land into first and second quadrant, according to the domain of it, and does not go below the x-axis, again with respect to this. Now, the other way to interpret this function, absolute value function, is to use the definition of absolute value. And at this stage of the course, students are already familiar with the definition of absolute value. So with respect to the definition of absolute value, we go ahead and make definition for the absolute value function. So we said that absolute value function, as I have written, is defined into two parts. One is for all the values that x can assume larger than, greater than or equal 0. And the second one is all the x's that are less than or equal to 0. You see that? Now, the graph of this one will be y equal to x, which is, we are familiar with, is a straight line with a slope of 1, 45 degrees in the first quadrant, and continues from first quadrant to the third, indefinitely both sides. All right? So we have perfect picture of this one in our head. And we also know that when y equals negative x, that is exactly like the other one, but is in the second quadrant, second and fourth quadrant. 45 degrees with respect to the x-axis and y-axis, and the graph will be a straight line with a slope of -1. So we have perfect shape of that one. Now, since it is a absolute value and the graph, we already mentioned, does not fall below the x-axis, therefore both of these lines, they will intersect and stop at the origin. So that makes it ray, as a matter of fact. So because we cannot say half a line. There is no such a thing as a half a line. Line has no head or tail. So we can say that absolute value is a union of two rays with the same initial point, origin 0, 0. And the other way that I already mentioned is that the graph of that, let me put that one up one more time, because x and negative x, f of x and negative x is what gives us same value, therefore this function will be what symmetric with respect to the y-axis. Again, the student at that stage, I'm repeating, are familiar already with the symmetry with respect to x-axis, y-axis, and a straight 45-degree angle line and others. Okay, now let's look at it. So we have a good picture of that, which will be, the graph should look like a V. V looking, and will be in the first and what as second quadrant. All right. Now let's look at it from another angle. And this angle, again, we are taking picture in our head. We are analyzing the graph, and we are not becoming mechanical, following recipes. That's not mathematics. I don't know what I call that one. But here, we know how the graph of, we already discussed that one, the graph of y equal to x is a straight line with a slope of 1, first quadrant and third quadrant, continues forever. Now, since we are already familiar with the graph of the absolute value function to be a V shape, so we notice that if we take the second part of it in the third quadrant, the mirror image of this with respect to the x-axis to be the mirror will be the second part of the absolute value function, the graph of that. Do you follow it? So the mirror image of that with respect to the x-axis will fall here, and that will be the graph of the absolute value function completely. Now, based on these all observations, mental picture that we got, we can have a complete picture of the graph of absolute value, and that will be the picture of that. And sorry for my primitive equipment. Now, this is the part that I just mentioned, but is in the third quadrant. So we reflected that one, and came to the second quadrant, and the graph will be this. So this is a perfect picture of the graph of absolute value function, which is going to be the parent function for us in this discussion. Are you with me so far? In a live class, of course, I will a little bit hesitate, pause, so that I make sure the student have comprehended perfectly. But here you have upper hand with the technology of computer to pause, think, reflect, contemplate, take a picture in your mind before you go further. Don't be mechanical. Don't follow recipes whatsoever. Okay, now let's go and see what happens to the graphical transformation of this parent graph of this absolute value. So we want to know how the transformed graph will look like when for a times the absolute value of x, where a is a constant number. So when I use the word number, it means real numbers often, and when used a number can be positive, negative, or 0. 0 and 1, of course, is trivial. Now, before I continue, let me say a few words aside that is not really related to this lecture, but give us some hint, some background, some information. Very, very useful, in fact, especially for freshman students. Now, the product of two numbers between 0 and 1 is smaller than either of the two. And the product of two numbers greater than 1 is larger than either of the two. And a square root of a number between 0 and 1 is larger than that number, and a square root of a number to the right of 1 is smaller than that number. Now, here I selected A to be a number between 0 and 1, and I selected to be 1/2 as a typical representative of all the numbers between 0 and 1. And then I selected number 2 to be a number to the right of 1 as a typical representative. And then I take the picture in my head. And the picture is that, let me see, here the graph that we discussed, that y equal to x, the slope of that was 1. Now, when it is 1/2, then we can put 1/2 here, so the slope becomes half. And again, at this stage of the course, the student do know what the slope means. So that means the slope of this y equal to x has become 1/2. What does that mean? That means, we have again a mental picture of that. That means that the transformed function when a equals 1/2 will be a kind of wider than the parent graph. If this is the graph of the parent, the graph of a number between 0 and 1 is selected half, the graph of that will be a little bit wider. Do you follow me? In other words, it contains the parent graph. A slope is less steep, 1/2 is less steep in a sense than 1, the original slope of the parent graph. And the very same is true with 2. When we go with 2, if this is the mother graph, the parent graph, when the slope is 2, which is more steep in a sense, then that the transformed function, the graph of that will be inside the parent's graph. Again, if this is the parent's graph, the graph of the number bigger than 1 will be inside this, will be narrower, will be a little bit skinnier. You follow me? Again, I want to get a good mental picture of the situation. Do not become mechanical. Do not follow recipes. And I keep saying that again and again and again because I have suffered a lot myself. Now, let's go through the discussing with, oh, by the way, I forgot to mention, I'm glad I wrote it here. And that is transformation in this case, or not rigid transformation, this transformation. Why? Because the parent graph was distorted. We have distorted to get the graph of 1/2 of x, and we distorted to get the graph of 2x from it. So that is not a rigid transformation, as we mentioned in the beginning of this lecture. Now, let's discuss about the graph transformation graph in this form, absolute value of x minus b, where b is a real number in this form. Now we want to discuss that one. Where b is a real number, what happens to that one? So I have already written that the initial, or I call it a mother function, what we call absolute value, let's call it the parent function. So this transformation, you want to see the look of that corresponding to the graph of the parent function. Now, again, we are not becoming mechanical. We are not following what? We are not following recipes. So we are going to analyze the graph of this for b. We select a number for b. We can select, let's say 2. I think I selected 2. Yeah, I selected 2. So we select a number and see how the graph of that, we can compare it to the parent graph. Because everything is being referred to the parent's graph, because parent's graph, we initially said that we are imposing the transformation on parent graph of absolute value function. I keep repeating because repetition is a good way of learning, especially for the beginners. Okay, now the graph. By the way, graph means always, in mathematics, that is reality. Mathematics, graph means set of ordered pairs. That's what graph means. Now the other one that we say graphic means a geometrical representation of that is the sketch of the graph. So this is analytical interpretation of that. You follow me? Now here, this is the graph, which is a set, graph of the what? Of the parent's function. And this is the graph of the transformed function, where b is 2. You see that? Now when we compare them, what you see, look at that. We notice that 0, 0 here is 2, 0, which means they have same height. The rate at which the y is going up is same. You see that? 1, 1, 2, 2, x, x. But at different point on the number line. Here we have 0, 0 at the origin. Here we have at 2, 0. Here we have 1, 1. Here we have at 3, 1. Which means when x is 3, then the y goes up 1 unit. Here when x is 1, y goes up 1 unit. And here when x is 2, y goes up 2 units. And here when x is 4, y goes 2 units. So from this interpretation, from the analysis of this, analytically, we notice that this is same as the graph of the parent's graph, the original graph, moved 2 units to the right. Do you follow me? So we have the mental picture of that. So let me not to be your mirror image, I turn. So if we take the parent graph, which is on the origin, the peak of it, the initial point of that, we move it, that is translation, that is a rigid transformation. And move it 2 units to the right and put it there, that is the graph of the transformed function. And we can do it another way, which is maybe easier and better, is that if this is the graph of the parent graph, by absolute value of x, then erase the y-axis and put it 2 units to the left. Put it there. What you get is the graph of the x, absolute value of x minus 2. Do you follow me? So the very same we can do it for other values for b. And so I have the sketch graph of that for the demonstration, and why not to look at it. But we have a good mental picture of that. So we want to reduce as much as possible the graph being mechanical and sketching. We want to analyze it analytically, and we want, because mathematics is what? Is think and reflect. Do not follow recipes. Okay, now I keep saying that because I have suffered. It's a long story to share with you. Okay, now here the transformation I've said is rigid, and that is the graph of that. You see that? It's 2 units. This is the parent's graph, and the parent graph has moved 2 units to the right. And that is same as is moving, you know, the y-axis was initially here, and I erased it and put it to the left. And that is the graph of the transformed function. What? A translation of the parent's graph, and is a rigid transformation. Okay, now let me talk about another interpretation. Why not? We want to learn analytically as much as we can to improve our comprehension as much as we can. Okay, now look at this one. This is the one that is with the blue color. I think you can see it clearly. I have written y equal to x. That is the graph of y equal to a slope of that is 1. All right? Now, how do you sketch the graph of y equal to x minus 2? When x is 0, y is negative 2. Is that right? And 2 points is necessary and sufficient to sketch a straight line, because 2 points determines a unique line. So one of the points is, let's say, when x is 0, y is negative 2, and when x is 2, y is 0. So I have my 2 points and I sketch that one. Now, what do you notice between these two? We notice that they have same what? Same slope. Isn't that right? But if you are talking about absolute value, then this graph, absolute value cannot fall below the x-axis for the parent graph. So the mirror image of this one with respect to the x-axis will be up. You follow? So if you are talking about the absolute value of this, exactly same thing happens. If we take the second, the line that is from that lands into the 4th and the 3rd quadrant, if you take that one, the mirror image of that with respect to the x-axis to be mirrored will be falling up. So the graph of that will be this way, that we have already seen it. So that is another way to analyze to interpret the transformation, the graph of transformation. Okay, now I have also sketched it. Why not? Let me put it here for those that they like to take notes somehow. Again, I did reflect it with respect to the x-axis, and the parent graph end up to be this with a dotted. You see that, and the transformed graph end up to be this. That's another way to interpret that one. Okay, now let's see what happens for when our graph is going to be y equals to, let me take this one out. Now we want to know what happens when we are dealing with y equals to, that I forgot to write it, let me write it right now, if I may, and that is, we want to know y is a function of x with the rule of correspondence to be absolute value of x plus c, where c is a constant number, positive, negative, or 0. Now, here again, we are analyzing, we are not becoming God, we are not becoming a parrot, we are not following recipes. Think, reflect, Contemplate before you do anything. All right. Now here we are comparing again the graph. I selected C to be 2. The graph of them. Again, graph is what? Is a set of ordered pairs. That's exactly what mathematical meaning of graph is. The other one is a sketch of the graph when we see it geometrically. Now here, this is the parent graph. Is that right? Now compare them. Compare them. We notice that, look at that. 0, 0, this is a 0, 2 more. You see, the y is 2 more than this. The y here is 1, the y here is 3, 2 more. The y here is 2, the y here is 2 more, which is 4. Which means the rate at which the y is raising, going up, remains same as the rate of the parent graph. The only difference is that everything is how many? 2 units up, because I selected C to be 2. So we have a good mental picture of it. This is the graph of what? The graph of the parent V-shape, all right? Then the graph of that plus 2 will be what? Will be moved 2 units up on the what? On the y-axis. The initial point will be moved 2 units up. And that is exactly the same thing as we erase the x-axis and move it 2 units down. That will be the graph of f of x equal to absolute value of x plus 2. And similarly, we can say C is negative or C is any other number that you have selected. Now I have sketched the graph of a few of them for your observation, if I may. And that is now here, when x is 2, as you notice, when x is 2, the parent graph is moved up 2 units, and that is a rigid transformation. And that is called translation. So we have translated the parent graph 2 units up. We got that one. And if, let's say, C is negative 2, then the parent graph is going to be moved 2 units down. Or again, we can erase the x-axis and deal with that going up or down. You follow me? Beautiful. So mathematics is fantastic. There is no anxiety whatsoever if it is learned correctly and also if it is taught correctly. That's very, very important. And it's a science of think and reflect. It's not a science of recipe following. It's not a science of parrot-like following recipes and being mechanical. Okay, now I keep saying that because finally, hopefully, sink in the head of my students. Now, what about if I combine all of them together now? A, B, and C. And I leave that one as a homework for you. What will happen to the what is a graphical transformation? What do we do to the parents graph in order to get that one? So you can select some number of your own. You can say A is, for example, 2 or 1/2, B is 3, and C is 5, or what have you, and then sketch this graph and see what happens. All right? All right. Now I have another one to discuss, and that is the final, the end. Of course, I could talk much more about that, but I try to reduce the time. Now here, we want to know how to analyze the graph of x squared minus 1. X squared minus 1. So it's not that you take x squared and move it 1 unit to the left or 1 unit to the right. That is not mathematics. Now, how do we interpret that one? Think, reflect before we go discuss that one. Now, in order to do that, we go ahead and sketch the graph of x squared minus 1. All right? I have done it. Let me show you. and then discuss about the meaning of the absolute value, which this one also reminds us about absolute value. All right? Now look, how does the graph of x squared minus 1 looks like? Again, probably at this stage of the course, the students are already familiar with that. That will be the graph of that. On the graph of x squared minus 1 is the parabola is 1 unit moved down the vertex of them. You happy with that? Now, here we were talking about the absolute value of that. Is that right? Not this one, but the absolute value of that. What does that mean? That means that we expect the graph not to fall below the x-axis. So the graph you are expecting to be in first and second quadrant only. We have mental picture of that. So what do you think the graph of absolute value of this will look like? Do you have the picture in your head? I'll give you a few seconds. If it is in large class, I walk around to see if a student have got the idea, if they can say how it looks like. And most of them, of course, they do at this stage, hopefully. Okay, now comes the moment of truth. Let's see how the graph of absolute value of x squared minus 1 will look like. Again, I went ahead and did that one, but I immediately come that the graph must not fall below the x-axis. So that means that will be the graph of absolute value of x squared minus 1. You follow? Very interesting, isn't that? This is the beauty of mathematics. Makes you fly. There is no anxiety in mathematics if it is learned correctly. It's a fascinating subject. It's the mother of all sciences. So that will be the graph of that, and this part of it is the mirror image of the previous one with respect to x to be the mirror. So the mirror image with respect to x will be the graph of absolute value of this. Okay then, I thank you for watching, and I hope that this lecture was beneficial for all of you. And as always, I wish you prosperity, happiness, good health, and please stay safe. So long.